Solving rational equations. This is section 7.6, number 1, and for all of the rational equations we solve, we're going to use the same three-step process. First, we're going to multiply both sides of the equation by the LCD, and that'll get rid of denominators for us, and then we'll just have a regular linear equation to solve without any fractions in it. Then we're going to solve the equation that's resulting from that, and check the solution. And we're going to have to be really careful to check the solutions and make sure we don't get any solution that gives us a 0 in the denominator. And we'll see a few problems further on that'll give us this problem. Right now, the first few problems we do out aren't going to have that issue. But it's still always good to check your solution. Just make sure it makes a true statement when you put it back into the original equation. All right, so let's start with this one here. We have 19y over 6 minus 5y over 2 equals 4. First we want to multiply by the LCD. Well, the LCD here would be 6. So let's multiply both sides of the equation by 6. When we multiply both sides of the equation, every single term in each side of the equation gets multiplied once by the multiplier. So that would give us 6 times 19y over 6 minus 6 times 5y over 2 equals 6 times 4. So let's go ahead now and do the cancels. 6 goes into 6, that's gone. 2 goes into 6 3 times, and nothing to cancel on the right. So now we're going to go ahead and simplify it. 19y take away 3 times 5 is 15 y equals 24, and we just keep solving the equation with the normal steps that we use. Combine like terms, 4y equals 24. Then we use the multiplication property to divide both sides by 4. Gets rid of the 4's. We get y all by itself, which is what we want. Y equals 6. And then for a check, we want to put this y equals 6 back into the original equation, which was 19y over 6 minus 5y over 2 equals 4. And we don't have to worry about a denominator going to 0 here because the denominators don't have any variables in them. So we're not going to be plugging in our 6 into the denominators. So we'll just put it in wherever we see a y. So 19 times 6 over 6 minus 5 times 6 over 2. The question is, does that equal 4? And it should equal 4 if this is a true solution. So let's do some canceling. Gives us 19 minus 15 equals 4. Yes, so it checks out. Y equals 6 is the solution. All right, let's try out another one. 7.6, number 2. And we're going to use the exact same steps here. Multiply by the LCD, solve the resulting equation, and then check the solution. And again, we have no variables in the denominator here, so we don't have to worry about a solution that's going to make a denominator go to 0, because the denominators are constant terms, constant numbers. Okay, so LCD would be 10. So let's multiply both sides of our equation by 10. And that means every single term gets the 10. And every term gets the 10 once. So we don't want to give the 10 to the first term here, the b, and then the 1. We don't want to give it to both. We want to give it to this single term. This is one term here. Just as this is one term, and this is one term. All right, so each term gets it once. So that gives us 10 times b over 5 minus 10 times b minus 1 over 10 equals 10 times 9 over 10. So give the LCD to everybody, to each term. And now we do our canceling and solve the equation like we normally would. So 5 goes into 10 twice, 10 and 10 cancel, 10 and 10 cancel. So that gives us 2b, take away. Now this entire numerator here is being subtracted. So to remind myself that the entire thing gets subtracted, I'm putting parentheses around it. Because if I don't put parentheses, I'm only subtracting the b. I'm not subtracting the 1. I want to subtract b minus 1. And that equals 9. Clearing parentheses, 2b minus b plus 1, so watch the sign change there, equals 9. Combine like terms, b plus 1 equals 9. Take away 1 on both sides, and we get our answer, b equals 8. And again, it would be good at this point to check it in the original equation, just make sure that it works. Again, we don't have to worry about the denominators going to 0 in this case because they have constants in the denominator. All right, so I'll leave the check for you. I'm going to go ahead and, I don't know if I can fit in one more problem. Let me see what the next one looks like. No, I'm going to start a new clip.